Hello everyone and good evening. Welcome to the OneClass channel. My name is Fajiro Rome and I am an honors Bachelor of Science graduate student working towards medical school. Tonight actually, we'll be going over some commonly asked chemistry questions at both the high school and college levels. If you need some extra help or just some more help with homework or tutoring, please click on the link in the description down below. And with that, we're going to get right started on question 1. Okay. So hopefully you can see my screen now. So, starts off with this question here, and it's asking us, in which of these solutions will HNO2, which is, I believe it's not nitric acid because it's NO2, not NO3. It's a different type of nitrous acid. But in which of these solutions will HNO2 ionize less than it does in pure water? So when it's put in pure water, we assume that it just ionizes completely. There's just different factors that can change how well it ionizes. So in these type of questions, it's always good to write down an equation. So I'm just going to put HNO2 plus water. In fact, before we put the plus, let's add the aqueous sign. It just helps us distinguish later, because usually the liquid isn't really part of the equation, it's just there as an extra piece. But pretty much it ionizes. In fact, in this case, I'll keep this out, because that's only if we're working with acids and bases, is where it's technically this is an acid, but that's not what the question is asking. It's just saying that it ionizes to form H plus and NO2 minus. It could have been written with water, but instead of the H plus, you would put like H3O plus, which is the actual hydronium ion. But this is enough of information that we need here. Okay, and these type of equations and reactions is that the more reactants, in Le Chatelier's principle, if you have more of the reactants, it'll push it towards the products. If you have more of the products, it'll push towards the reactants. Now it's asking us which will make it ionize less, meaning that less of these. Okay, that means you want something that increases the products to push it to the reactants. Okay, now let's see what it gives us. It starts off with, first one is 0.10 moles of NaCl, so just salt. B would be 0.1 moles per liter, that's a molarity of Kn, because that's what the big M is. Sorry about that. So the big M is not moles, it's the molarity, which is in moles per liter. Okay. C is the same, 0.10 moles per liter of NaOH. And D, the last one, is also 0.10 moles per liter of NaNO2. Now, as I said earlier, we know something that increases the products. NaCl doesn't really react with this equation. It would just make the solution just more concentrated. So this one, we can say pretty much not really, won't change anything. KNO3. NO3 is close but no cigar. That one won't really react with this equation here, so we can just cross that one out. NaOH, same thing. Both parts of it don't really have any business interacting with it. Now sodium nitrite, that would be what it is. This one actually has an NO2 we're looking for. Okay, and this one, especially with sodium, it likes to dissociate completely. So in the solution, you actually see Na plus and NO2 plus as well. Now these products will be competing with what we have here, meaning that now, NO2 minus, but now we have a lot of NO2, which based on the Chatelier's principle would push the reaction towards keeping it as HNO2, meaning that it would ionize less. So for this question, D is the correct answer, as it's the only one that has similar properties of what we're working with. aka the NO2, similar products, so it's pushing the HNO2 to the reactant side, hence ionizing less. So that's how we solve question 1 there. Let's see how we did here. So it skips right to it, just says option D is correct, and let's see what they say. Oh wow, they actually mentioned the Taylor's principle. I'm glad I know my stuff. But yes, exactly. It's pushing the equilibrium towards the reactants because of the fact that there's NO2 minus present in NaONO2. So this is correct, and we can just go straight to